Hi guys, we're going to talk about inequalities today for the second section of ingenuity. First, we're just going to remember how do we graph inequalities? So when you think of this statement, this is saying x is greater than equal to 2. So that means what numbers for x can be bigger than equal to 2? What would make that true? Well, 3 definitely makes it true. 4 would make it true. 10 would make it true. 2.1 is greater than or equal to 2. 2 is greater than or equal to 2. So since you cannot list them out because there are infinitely many, then what we do is we graph a picture of what the solutions are. Because if you graph a picture, you can infer all the infinitely many solutions. So you need to make sure that 2 is on your graph. And because x can equal 2, we do a solid circle. And then what numbers are bigger than 2? All of these numbers to the right. It says greater than will be this way, and then you would shade in the arrow. I've seen kids do it like this before too. That would be fine with me. Some teachers may have you memorize that if the variable's on this side, that it can kind of be like an arrow. That's fine. Just make sure that you always have the variable on the left side, or you just think it through to say which numbers make that true. Okay, so this one, x is less than negative 12. What numbers are less than negative 12? Negatives can be tricky, remember. So, little glitcher there. If 0 is here, what's less than negative 12? Well, negative 13 is less than negative 12. Negative 14, we're talking about numbers down here or where is less. Cannot be negative 12 because it's just a less than sign. So we do an open circle, shade to the left. Some things that I've remembered over the years, the word less than, if you have the less than sign and you straighten it up, it would turn into an L. That's how I know that's a less than, and then this would be a backwards L, so it's greater than. Just something that might help you. Okay, so what is the difference between a solution versus solution set? Well, in this example here, you would just have a solution. X would equal Y, because there's only a possible way that could work out. But if x is less than y, there are lots of values for x that would be less than this value of y. So that's what we're talking about. Solution set means there's be many, and a solution would just be one. So if negative 4 is x and y is negative 3 halves, negative 3 halves is the same thing as negative 1.5 if you need a reference point. They're definitely not equal, so I'm going to go ahead and cross this out. If you need to think of a number line, please do. Is negative 4 bigger than negative 1.5, or is it less than negative 1.5? Well, if negative 4 is here, negative 1.5 would be here. Negative 4 is less. So the alligator mouth is hungry. It eats the bigger numbers. It's going to eat the negative 1.5. So the solution that we have would be this one. X is less than y. Okay, solution set of an inequality is all the numbers that make this true. So let's look at this guy. They're asking, is 3 a solution to this? So you have to say, is it part of the solutions? Well, does 3 plus 1, is that less than 4? The answer is no, it's equal to 4. So it would not be part of the solution set, and it would not be in the picture of the graph when we are done. Next slide. It's kind of hard to teach this with the mask on. Okay, which values are solutions to this inequality? Which ones would be in the shaded graph when we're done? Would negative 4 be there? So let's see if it makes it true. Is negative 3 times negative 4 minus 4? Does that give you a value that is less than 2? Be careful with signs. This would be 12 minus 4 is less than 2. Is 8 less than 2? No. So that would not be in the shaded region. How about negative 2? Negative 3 times negative 2 minus 4. Is that less than 2? So you have 6 minus 4. That's not going to be less than 2. That would be equal to 2. So that is also not going to be in my solution set. We can give 0 a try. 0 is always a nice number to plug in because things drop out and it works out pretty easily. If you take negative 3 times 0, that just gives you 0. So then it's just as negative 4 less than 2? Yes, negative 4 is less than 2. 0 is part of the solution set. Is 3 part of the solution set? Negative 3 times 3 minus 4, is that less than 2? Negative 9 minus 4, that would give me negative 13. Negative 13 is indeed less than 2. So 0 and 3 would be in the solution set. Now this is kind of tedious and stupid to keep plugging in all these values. Is there a better way? Yeah, we could graph it. We could solve it to find a solution set, and then you could just check to see at these values. Now we're going to use these properties I'm going to show you on the next page. But basically, you treat it very much like a equation with probably one main exception. Okay, so what are the rules? The addition property is the same as it worked for equality. If you have, let's say 10 is bigger than 5. Everyone agrees with that? If I add the same amount to both sides here, the inequality will still hold true. 17 is still bigger than 12. So you can add or you can subtract. I like to think of a barbell. If one side's heavier than the other and you removed the same amount of weight from each side, they're still going to be unequal that way. The same is true with subtraction, addition and subtraction. Okay, now, if A is less than B and B is less than C, then A is less than C. This transitive idea, it always looks like a train because it's pretty long. That would be like saying if 10 is less than, what, 15? Okay, that's true. Well, we know that 15 is less than 20. So then 10 has to be less than 20 because it would be the order they would appear on the number line. The same is true for greater than. If 30 is bigger than 7, and we know 7 is greater than negative 9, then isn't 30 bigger than negative 9? Yes, the answer is correct. So that is the transitive property of inequality. What else do we have here? We have multiplication property, and these are the big ones. This is the sticker. I used to tell my kids that the math police comes all the time when we do with inequalities, and I would make like a siren noise, and I thought it was really funny, but then one time a kid told me it sounded like a dying cat, so I don't make the siren noise anymore. But what this is saying is if you multiply, something weird might happen. So there's two cases. This is saying if C is greater than 0. If C is positive, which means you're multiplying by a positive number, I want you to see what happens. Okay, so 10 is less than 13. Everyone agrees with that? Okay, let's say C is a positive number. Let's say C is going to be 2. If I multiply both sides by 2, I get 20 is less than 26, and there's no big deal. Okay, kids do that correctly. That is not the problem. The same is true if the sign was flipped. If I have 5 is bigger than 4, multiply both sides by 2, if that's what C was, 10 is still greater than 8, no issues. Where the issue shows up is here. If C is negative, so let's say C is negative 2, and we said 10 is less than, let's say, 8 this time. That's not even true. 13 is what I did, I think. I don't remember. 10 is less than 13. Watch what happens when I multiply by negative 2. I get negative 20 and negative 26. If the sign was to say the same, that would tell you that negative 26 is bigger, but that's not true. So if you see, when you multiply by a negative, you have to flip the sign. Because when you multiply a negative and positive together, it changes its value. So the number would become more negative, and that would move it further away on the number line. So you have to flip the sign. The same is true if you have a greater than, then it would become to less than. So the rule kids need to know is, erase. If multiplying an inequality by a negative number, make sure you flip the inequality. If not, you're going to get something that's not true. So that is the multiplication property. You have to be very careful with the negative numbers because there is two cases. Positive numbers does not cause a problem, just a negative. So if you say the words multiply by negative, you need to be ready to flip the sign. So let's look at this example. Back to your old geometry days. How can we solve this? Well, the first thing you're going to do on this problem, I feel like, okay, they changed the problem from originally. This is given. That's the problem they give it. What will we do to solve this? We want to know what x values make this true. So the first thing you would do is add 2, and this is the addition property of inequality. And I get 3x is, keep the sign because you don't change anything there, is greater than negative 2. Then you divide both sides by 3. Dividing would follow the multiplication property. The same rules would be true on multiplication as division because that would be multiplying by its inverse. You do not have to flip the sign because 3 is positive. X is greater than negative 2/3. So that would be the multiplication property of inequality. And I can graph this to show me a picture of all the solutions. I would put negative 2/3. I like to put 0 as a reference. Negative 2/3 on my number line. It cannot be negative 2/3. So it'll be an open circle. And where are values bigger than negative 2/3? That would be everything to the right. So all of these numbers would make this inequality true. Okay, here's another one. They've got the steps here if you want it. We're going to treat it like a equal sign until you multiply or divide by negative. So we're going to get rid of these grouping symbols, and I call that cleaning up. We're going to clean up the equation a little bit. Continue to clean up by simplifying. Then we'll get the variable by itself or isolate it, and then you'll solve it. Checking is usually important with inequalities to make sure you didn't forget to flip the sign. So let's clean up a little bit. That's the distributed property. 2x minus 8. Keep the sign, less than equal to. I'm going to go ahead and do 2 steps here because I'm going to clean up this right side while I'm at it. X plus 3x, we call those like terms. That would be 4x plus 15. Okay, now let's get our x's together and get our numbers on the other side. We're going to isolate the variable. Some kids always like to move the smaller of the variables. That is fine. I like to move my x to the left, so I'm going to go ahead and subtract 4x here. If you went the other route, you will get the same thing. So I have negative 2x minus 8, less than equal to 15. That's personal preference. You could have moved the 2x over there. I'll add 8. This is the addition property of inequality. Negative 2x less than equal to 23. And, oh, looky here. We're saying the words divide by negative. That's that multiply. You're multiplying or dividing by negative, so you're going to have to flip that inequality. X, instead of less than, we're going to go with greater than equal to negative 23 over 2. Now, if you want a decimal approximation to help you graph, I'm looking at about 11.5. So X is greater than equal to about a negative 11.5. You can graph it. So here's 0. Here's negative 11.5. It can equal that. That's good. And it can be bigger than that. So anything to the right. So if you want to check, what you can do is you can pick one of these numbers to see if you shaded the right side. As mentioned earlier, 0 is really easy to pick. You can plug it into the beginning. That's probably the best thing to do. But I'm going to plug it in right here. Because if I plug it in right here, this will become 0. And this will become 0. And I can check real easy. Negative 8 is less than equal to 15. I like the way my graph looks. I feel pretty good. Okay, here's another inequality to practice. First, we will add the 3. And I get negative 3x less than equal to 9. You divide both sides by negative 3, which does cause problems because you're multiplying or dividing by a negative. We will flip the sign to go the other way. Negative 3. Here's 0. Here's negative 3. Solid circle at the negative 3 because it can equal negative 3. Everything shaded to the right. Again, you can plug in 0 to check since it is in my solution set. Is -3 less than or equal to 6? Because if I plug 0 in, that will drop out. And the answer is yes, I did a good job. Okay, these two are what we call the specials. So what happens here? Let's see. Let's clean this up. And I get 2x minus 7 less than or equal to -8. Be careful with the distributing of the negative here. That will become a plus 2x. We're then supposed to get our variables together. So I'm going to subtract 2x here and subtract 2x. And oh, dogs, look what happens. Oh, dogs. I get -7 is less than or equal to -8. How do you feel about that? Is -7 less than or equal to -8? Well, if here's -7, -8 would be over here. Is -7 less than -8? No. That is a big fat lie. If it is a lie, that means it's not true. Because it is not true, that means that this particular inequality has no solution. Nothing makes it true. And I want you to think about how you could have caught that earlier if you were using your brain a little bit, but nobody likes to use their brain when they're doing these math problems. 2x minus 7 less than or equal to -8, we said, plus 2x. I can write that as 2x minus 8. Think about it. If I have a number and I double it and I subtract 7, will that ever be smaller than if I subtract 8? No, if I subtract 8, that's the one that's going to be smaller. So there's no solution. So the first special is called a no solution. You can call it empty set, or you can just write the word no solution. I think they might call it empty set too. Okay, so let's see what the other special is. Okay, we're going to clean this up. This would be 4x plus 8 greater than 1 plus 4x. This is a very similar thing if you catch it here. When I subtract the 4x, I get 8 is bigger than 1. Well, how do you feel that? You're like, yeah, it is. That's true. When is it true? It's always true. Because it's always true, we say that this has infinitely many solutions. The entire graph is a solution set. Anything can be an answer. You might go like this and just color the whole graph. You might say negative infinity to positive infinity as an answer set. There's lots of different things you might say here. So everything makes it true. All real numbers makes it true because if you add 1 to a number that's multiplied by 4, it's always going to be less than if you add 8. All right, going back real quick because I'm going to end the video here. I'm a little worried that I forgot something. On some of these graphs, I'm going to try to find one here. I don't know. There's other ways you can write it other than the graph. Okay. I don't know if you're going to have to do this or not, so I'm just going to show you real quick. Let's say that don't look at these. Let's say that this is my graph. This is a perfect graph. They might want you to say the solution set is this. It's all numbers from 3 to infinity. Now, we always put a parenthesis by infinity because you can never be infinity. And because it cannot be 3 here, we would do a parenthesis here. So this is telling you that this picture of solutions is everything from 3 to infinity. You could also, if you had a solid circle here, let's say it was -4 and negative infinity, you always do the small number first. So the graph picture is the smallest number is negative infinity. Once again, I do a parenthesis because you cannot be negative infinity, but you get really close to it. And this time it goes all the way to -4 as my big number. Because it can equal -4, we put a bracket there. That means it can equal. Bracket means the same as the solid circle. Open circle means parenthesis. So you can write these graphs in what we call interval notation, like this. I don't remember for sure if you have to do it or not. We can talk further about that if it comes up. come see me during office hours. Okay, I'm going to stop this first tape because the next ones we're going to do are the compound inequalities.